This video will be filling in the bottom flap of section number 2 of your Unit 8 Trigonometry flipbook. The bottom section of section number 2. We've already gone through an example in section number, I think it was section number 1. Yeah, section number 1 of how to find the length of a missing side of a right triangle using trigonometry. Let's go through a few more practice problems there. So if you would, class, go ahead and fill out your essential question on this video. How do I find the missing side length of a right triangle using trigonometry? How do I find the missing side length of a right triangle using trigonometry? Let's write a couple notes here on the left side before we continue with this. Here is an example triangle ABC, and we're going to remind ourselves of that trig abbreviation that helps us remember our trig ratios. It is SO, CA, and TOA. And recall, class, sine, SOH, sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tangent equals opposite over adjacent. Now let's go ahead and label the sides of this triangle, and they're going to be in small letters. Let's say that side is B, and this side is small case c, and this side is small or lowercase a. So here's our review. Let's say that we decide to use angle A as our reference. Angle A is our reference angle. So, if angle A is our reference angle, then let's look at all the ratios, how they set up with trigonometry. Okay, first one's going to be, what is sine? Well, sine of angle A is equal to opposite over hypotenuse. Take a look at reference angle A. The opposite side is small case a, and our hypotenuse is always going to be C. That's the side that doesn't touch the right angle. So sine of angle A is going to be the ratio A over C. Cosine of angle A is going to be equal to, and look at cosine is adjacent over hypotenuse. Adjacent to angle A is side B or leg B. B over hypotenuse, so B over C. And then tangent to angle A, well, let's take a look at SOHCAHTOA. Tangent is opposite over adjacent. Take a look at angle A. The leg opposite of angle A is small a, and the leg adjacent to angle A is small b. So tangent in this case is going to be A over B. But now the game changes when you change your reference angle. Let's say that you decided to use angle B is your reference angle. So now angle B is going to be your reference angle. Watch what this does to your trig setup. Now sine of B, here's our reference angle, sine of B. Well, if B is our reference angle, since sine is opposite over hypotenuse, the side opposite to angle B is small b. C is, of course, always the hypotenuse. So now the sine of B is small b over the hypotenuse. Cosine of angle B, well, take a look. Cosine is adjacent over hypotenuse. Look at our reference angle B. The leg that's adjacent to or next to angle B is A, and the hypotenuse is C. So cosine of angle B is A over C. And then our last one, tangent of B. Tangent of angle B. Well, here's angle B. Tangent is opposite over adjacent. Opposite of angle B is small b. Adjacent leg to angle B is A, that's next to B, so tangent is going to be B over A. Now look at the difference between these. If you pick reference angle A, these are your ratios, sine, cosine, tangent. Look at what happens if you change the reference angle to angle B. Tangent flips upside down from A to B to B to A. Sine and cosine now change. Sine of A was A over C. Cosine of B is A over C. Cosine of A was B over C. Sine of B is B over C. So again, you need to have a thorough understanding about how to find opposite sides to a reference angle and adjacent sides. The hypotenuse never changes. So let's go ahead and use this information and let's solve our first question. First question is, what is the length of AB? Let's go through our steps. First thing you do, class, is you write so ka toa. Next step we learned from our previous video is let's choose our reference angle. Our reference angle. Now the reference angle is usually the one you know. We know angle B is 38 degrees. So let's pick that as our reference angle. So angle B is going to be our reference angle. Okay? Let's figure out what we know and what we want to know. So we're going to write down here. I'll change color so you can see this. What do we know? What side do we know? Well, if B is our reference angle, AB is our hypotenuse, always. AC is opposite, and BC is adjacent. So look, class, we know the length of AC. And that means we know the opposite side of angle B. Let's underline O for opposite and O for opposite. Okay, now, what do we want? I'll put some underlines here so you see what we filled out. Angle B, we know opposite. What side do we want? We want side AB. That is the hypotenuse. So every time you set up a trig problem, you have to figure out what your reference angle is, figure out what side you know and what side you want to know. And since we want to know the hypotenuse, let's underline H and H. Take a look, class. The only trig ratio that has both sides underlined is sine. That means we're going to use sine. Alright, let's set it up just like we did in the previous video. Sine of angle B is equal to, well, we know sine is opposite over hypotenuse. So now let's fill in the things we know. Sine of angle B is 38 degrees. 38 degrees is equal to, we know opposite is 13, and the hypotenuse is our unknown side, AB. 13 over AB. Alright, we got to get AB by itself. Now I'm going to show you a math trick, class. We did all the steps in the last video, but a math trick here is, if you think about this as a proportion, and I'll write this in a different color so you see this. If you think about this as a proportion, this is sine of 38 over 1 equals 13 over AB. We can actually switch AB and sine of 38 around, and we do not change our answer. It's the same as multiplying both sides by AB and dividing both sides by the sine of 38. So we can actually rewrite this equation directly. In this case, I can rewrite this as AB is equal to 13 over the sine of 38. Now if you don't understand that, don't worry about it. Multiply both sides by AB, so AB moves to the left, then divide both sides by sine of 38, and sine of 38 ends up on the bottom of our fraction on the right side. Let's go ahead and plug this into our calculator. And AB is going to be approximately, let's pull up our calculator here, 13 divided by the sine of 38, close your parenthesis, equals 21.1 is our rounded answer. So approximately 21.1, and our unit of measure is millimeters. Now we're going to do the next example much faster because you've already gone through the details with you. Alright, what is the length? What is the length of CB? Alright, oh, you know what, class? Change this. I want you to cross that off and change that to AC. I want to know the length of AC in this one. So what's the length of AC? Step number 1. You're going to write so SOHCAHTOA. Next step, what is our reference angle? What is our reference angle? Well, the only angle we know as a reference angle is angle A. So A is going to be our reference angle. I will circle that. All right, next thing is, what do we know? What side do we know? Well, we know the hypotenuse. AB is the hypotenuse. What side do we want to know? Well, let's name them. If angle A is our reference angle, then this is the hypotenuse. BC is opposite of angle A. AC is next to or adjacent to angle A. We want to know AC, so we want to know adjacent. Let's underline the parts of the SOHCAHTOA that we know, that we want to figure out. We know the hypotenuse, so underline H and H. We want to know adjacent, so underline A and A. The only trig ratio that has both sections underlined is cosine. That means our equation is going to use cosine. Cosine of angle A is equal to, now cosine is adjacent over hypotenuse. Okay, let's plug in what we know. Cosine angle A is 47 degrees is equal to, adjacent is what we don't know, that's AC. Hypotenuse we know, 56. All I got to do now, class, is get AC by itself. If I multiply both sides by 56, then the 56 cancels on the right and moves over to the left. So this is the same as 56 times cosine of 47 is equal to AC. Let's go ahead and put that in our calculator. AC is going to be approximately, let's pull up our calculator, and I'll clear this. It's 56 times cosine of 47, close your parentheses, equal, and our answer is 38.19. We can abbreviate that to 38.2. So AC is approximately 38.2. Our unit of measure is feet. Now, as you get good at this class, you'll be able to skip some of these steps, but please, would you listen to your teacher? Don't skip any steps until you get very good at this. Write SOHCAHTOA. Write your reference angle, what side you know, what side you want to know. Underline the letters that you are looking for, hypotenuse and adjacent. Circle the correct trig ratio. Write your equation, plug in what you know, get your unknown side to be by itself, and then plug the rest of the equation in your calculator and find out what the value of that side is. So there are some good examples of how to use trigonometry to find missing side lengths.